Our accelerated pre-calc lesson 3.4, solving exponential and log equations. So let's take a look at the lesson's key ideas. Okay, so basically the problems that you guys will get, they'll either be in exponent form or log or natural log form. So depending on what form you get, you're going to be solving them in different ways. So if they're in exponent form, there's typically three types of problems that you're going to encounter. The first one are problems where you can get the same base. So if you can get the same base, then get the same base and then set the exponents equal. And if for some reason you can't get the same base, you would log both sides, then solve for x. And then there will be problems where the base of the exponent will be e. So if the base is e, generally you'll want to isolate e and then natural log both sides and then solve for x. Unless the problem happens to be like some sort of quadratic or something like that, and you'll see an example of that later. Okay. So log and log form problems. All right. So if you have a problem that's in log or log form, what you generally want to do is you want to condense the log or natural log into one single log or natural log. And once you do that, then you convert it to exponent form. And then once the problem is in exponent form, then you want to solve for x. Okay, and then we'll also do some examples of that too. So let's take a look at exponent form first. So let's say, and I'll just make up some equations here. Say we need to solve, and you have like 8 to the 2x minus 5 is equal to, let's say, 16. Okay, so when you get a problem like this, you have to recognize that, hey, it's an exponent form. Can I get the same base? You always try and get the same base first if you can. Okay, so looking at these values, I am going to be able to get the same base because 8 I know is 2 to the third power. Then we still have the 2x minus 5 out here. 16, I know 16 is 2 to the fourth power. Alright, so we follow exponent rules. That's just going to give us 2 to the 6x minus 15 is equal to 2 to the fourth. Once you have the same base, alright, if the bases are equal, that means the exponents have to be equal also. So now you can take the exponents and set them equal to each other. And then you just do the algebra. You'll get 6x is equal to, add 15 on both sides, 19 divided by 6 on both sides. All right, and then that'll be your answer. Okay, you can't reduce it, so there's nothing else for you to do. And you actually want to check to see if your answer is correct. If you take this right here, it's 19 over 6. If you plug it in here for x and you simplify that, that should give you 4. All right, unless you did something wrong. So when you can get the same base, that's what you would do. All right, let's take a look at another same base problem. Let's see, we have like 1 over 27 to the 3x power is equal to 81. Right. So looking at these values here, I know that I'm gonna be able to get 3 as a base. So if I could get the same base, that's what I'm gonna try and do. So basically 1 over 27, I know that's 3 to the negative third. Right. Then you have 3x here. 81 is 3 to the fourth. So follow exponent rules, we would get 3 to the negative 9. 9x is equal to 3 to the fourth. And then once we have the same base, the exponents have to be equal also. So we set them equal to each other. So x is just going to be negative 4 over 9. Alright. So when you have exponential, when you're solving and you have exponential problems, problems that are in exponential form, see if you can get the same base first. Alright. Alright, so let's take a look at this problem here where we need to solve. Now, it's in exponent form, but can we get the same base? No. So if you can't get the same base, what you want to do is you want to log both sides. And the reason why you want to do that is because now the exponent right here, right, if you follow the power property for logarithms, this exponent gets to move to the front of the log. Right? And I like to put that parentheses there because this is one whole term right here. So once this moves to the front right here, we have 2x minus 1 times log 6 is equal to log 9. And then now you can use algebra to manipulate this to get x by itself. So we want to get rid of the log 6, so we divide by log 6 on both sides. So that's gone. So now we get 2x minus 1 is equal to log 9 divided by log 6. And then we're going to add 1 on both sides. So we add 1 right there. That's gone. So we have this. Now we only have the 2x over here, right? Is equal to this right here. So I'll divide both sides by 2. So our final answer is going to be, I'll write it over here once these cancel out. So we have x is equal to log 9 divided by log 6 plus 1 all divided by 2. Okay, and then what you would do is you would calculate this in a calculator to actually get a final answer. So if you were to actually calculate this in a calculator, you would end up with x is equal to 1.1131. Remember, we're always going to round to 4 decimals. Okay. Okay, another type of problem that we'll have is when the base is e. So when the base is e, you want to get this right here by itself. So we would minus 4 first. We get 2e to the 5x plus 1 power is equal to 5. Divide by 2. So then we get e to the 5x plus 1 power is equal to 5 over 2. Once e is by itself, so we don't want x to be in the exponent location, right? So what you're going to do is you're going to natural log both sides. When you do that, basically natural log and e, think of it as they're inverses of each other, they undo each other, so these typically just cancel out, and then you're just going to end up with 5x plus 1 is equal to the natural log of 5 over 2. Alright, and then we just finish the problem using some algebra. Minus 1 on both sides. Divide by 5. Alright, so x is going to equal this value right here. And if we actually calculate this on the calculator, this would be this would roughly be negative 0.0167. Okay. Okay, now let's take a look at some problems that are in log form or natural log form. Okay. So when the problem is given to you in log form, what you want to do is you want to make it a single log if it's not already a single log. Okay, so this problem is already a single log, so we don't need to do any sort of condensing. Alright, so once it's a single log, what you want to do is you want to change this to exponent form. In exponent form, this is going to be 2 to the 6th power is going to equal 3x minus 4. Alright, you notice this 3x minus 4 is in parentheses. Alright, that means this whole quantity, alright, belongs to this log. Okay, and then 2 to the 6th, now you just change that 2 to the 6th, we know that's going to be 64. And then we have 3x minus 4, and then you just use algebra to finish the rest of the problem. Alright, we get 68 divided by 3. So x is equal to 68 over 3. And you could just leave it like that. If you want to divide and get a decimal, that's fine, but you could just leave your answer like that. Let's take a look at another example. So taking a look at this example here, you have to be careful with a problem like this, because you notice this value here is not in parentheses. So the only thing that belongs to this log here is 5x. Basically, this problem is log base 4 of 5x plus 2. Okay, so when there is not a parentheses here, what you want to do is you need to get rid of this plus 2 first before you change to exponent form. If you change this to exponent form right now, if you say this is 4 to the 6th power is equal to 5x plus 2, this would be incorrect. Okay, so be careful about that. So if there was a parentheses here, then you could go change it to exponent form. But since there isn't, what you're supposed to do is minus 2 first, right? Let me erase this right here. So that now you get log base 4 of 5x is equal to 4, right? So now that you have this log by itself, right, now you can change it to exponent form. So in exponent form, we're going to end up with 4 to the 4th power is equal to 5x, and we know 4 to the 4th power, that's going to give us 256 is equal to 5x divided by 5. And then we get our answer, and you could just leave it like that or divide and get a decimal of it. It's really up to you. Okay? Alright, so let's take a look at the next example here. So we've got a natural log this time, right? So this is not a single natural log, so we have to condense here to make it a single natural log, right? So sometimes you're going to have to do some work and use the log properties and condense the problems. So over here, if we condense this would be natural log x squared divided by 3 is equal to 5. So once you've condensed it, now we can change this to exponent form. Now remember, a natural log, the base is always e. So when you convert this, this is e to the 5th power is equal to x squared over 3. Okay? And then we're just going to do the algebra, so we we multiply both sides by 3. That's gone right there. So we get x squared is equal to 3 times e to the 5th power. And then we square root both sides. Alright, so x is going to equal plus or minus, right? We need the plus or minus right here. The square root of 3 times e to the 5th power, right? And now you would calculate this with a calculator, so that's going to give you roughly plus or minus 21.1007. Alright, so we have two solutions here, positive 21.1007 and negative 21.1007. Now you have to be careful because your solutions here, if you take the negative 21.1007, alright, just think of it as negative 21. Can you take this and can you plug it in here? Right? Can we plug negative 21.1007 into right here? Right? Remember, we can never have a log, alright, and have this value here be 0 or negative, right? This can never happen. Okay? So you cannot take the natural log of a negative value. Alright? So the negative answer we are not going to include as our solution. So your only answer that you should include is only the positive. Okay? So you should really technically check all your answers all the time, plug them into the original problem, and make sure you don't get any logs or natural logs that are negative or 0. Okay? So be careful about that. Alright, so let's take a look at another example here. Now this is an exponential equation, but it's different because it's in quadratic form. Alright? So when you get a problem like this, you have to recognize, hey, that looks like a quadratic. I'm going to set it equal to 0. And then what you're going to do is you're going to factor this. I know it looks kind of weird to factor, but basically this is e to the x, and you have minus 2 and minus 1. Okay? Because what happens if you multiply e to the x times e to the x, you would get e. Alright, remember you're adding the exponents. Wouldn't that give you 2x? And then when you multiply here, that's going to give you negative e to the x. When you multiply here, that'll give you negative 2 e to the x. Alright, which means these are like terms now, right? So that doesn't give you negative 3 e to the x. Then when you multiply here, that gives you positive 2. Okay? So this is how you factor a quadratic. Alright, that's an exponential equation. Alright, I know it looks a little bit weird, but I think now that you guys have seen it, you guys can do it. So now once you've done this, what you want to do is you want to take each factor, set it equal to 0. Okay, so e to the x minus 1 equal to 0. Then the rest of it's real basic. You add 2 to both sides. And now that e to the x is by itself, what do? We're going to natural log like we did earlier. So x is going to equal natural log 2. Over here, add 1 over here. And then we natural log both sides. We get, we get x is going to equal natural log 1. Alright, when you get natural log 1 here, you want to be careful because you don't want to stop there, because e to what power is going to give you 1? Well, 0. So this actually really equals 0. Okay, so make sure you don't stop here and just give me natural log 1, because e to the 0 power, right? E to the 0 power is going to give you 1. So this right here actually equals 0. Alright, so let's take a look at this example here. So we have example B, log base 3 of 5x minus 1 is equal to log base 3 of x plus 7. So basically the idea is this. You know how when you have the same base, right? You can take the exponents and make them equal to each other. Because basically the left side and the right side has to be exactly the same, right? That's why we could make this equal to this right here. This is the same idea. Since the left and right side have to be exactly the same, and because these logs are exactly the same, we could just say, hey, 5x minus 1 has to equal x plus 7. And then you just do the algebra, you minus x, you get 4x, you add 1, you get 8, you divide by 4, so x is going to equal 2. Okay? So that's the idea behind this. So if these logs are exactly the same, that means that these values have to be equal to each other. You can set them equal to each other. Okay. Alright, so let's take a look at this example here. So it's in log form. Okay, so the problem is in log form. So we want to get the log by itself, right? So what you want to do here first is you're going to divide both sides by 2. So you get log base 5 of 3x is equal to 2. Because you want to get the log by itself. So now you're going to change it to exponent form. So now we have 5 to the second power is equal to 3x. So that's just 25 is equal to 3x. Divide both sides by 3. So x is going to equal 25 over 3. Alright, as your answer. So nothing complicated. Okay. Alright, so let's take a look at this example here. So we've got a natural log, right? And so we need to condense here first too. So we have natural log x minus 2 times 2x minus 3 is equal to 2 natural log x. And if you want, you could take this and move it over here as the exponent right now already. Alright, so that would, you could just do that right there, right now. So I would FOIL this right here. So natural log, so that'll give you 2x squared, that'll be minus 3 minus 4, so minus 7x, and then plus 6 is equal to natural log x squared. So using the same idea that we had before about the logs, if you have a natural log over here and a natural log over here, that essentially means that this and this value have to be equal, right? So these have to be equal because the left side and the right side are going to have to be equal to each other, right? So since that's the case, we could just take 2x squared minus 7x plus 6, set it equal to x squared. And then you've just got a quadratic here, right? Set it equal to 0 and solve for it, so we minus x squared. So you get x squared minus 7x plus 6 is equal to 0. So we factor this guy right here, x minus 6, x minus 1 is equal to 0. So your solutions are going to be 6 and 1. Okay? Now, like I said, you should always check your answers. If I take 6 here and I plug it into the original problem, if I put 6 in right here, 6 minus 2, that gives me 4. 12 minus 3, that gives me 9. Alright, if I plug in a 6 right here, natural log of 6, that's perfectly fine. So we know 6 is perfectly fine. Alright, it checks out. But look what happens when you plug in the 1. Alright, if you plug in 1, right, can we have 1 minus 2? No, we're going to get a natural log of negative 1. You cannot have the natural log of some negative value, right? The same way you can have the log of some negative value. So you know 1 here does not work. It's an extraneous solution. So your only answer is x is equal to 6. Okay?